Okay, so moving on from the series of workbooks and solutions and your own work with respect to the Excel spreadsheets that you've been working through. This is a template I'm willing to share with you guys. It's from a project I did myself, let's say a number of years ago. Again, like a lot of different projects, every life cycle costing exercise you tend to do is a bit different, slightly different, and can be very different depending on the project. So you can use a template, you can use a starting point, but you tend to have to make significant changes, not like maybe using a cost plan template or a bill of quantities that you've done before and changing some descriptions based on a similar project. This is essentially can be very different. Again, you can start with something you've worked on before. The calculations are intact, the formulas are intact, but there can be a significant amount of work to make that a complete life cycle costing exercise. This one is a fairly simple, straightforward template. It can maybe grows on what you've done before with respect to formulas. Gets a little bit more complicated, a little bit more intuitive in relation to automated calculations. Now, you don't necessarily have to follow exactly what's in the formulas. I'll give you an example of what's in the formulas in a moment. You can kind of take it as tried and tested and maybe use it as is. Or if you can figure out, depending on your skill set in Excel, if you can't figure out what the formulas are, you may be able to adjust them, change them, make them even more appropriate to your actual particular exercise you're carrying out. So what we have here is a simple one sheet spreadsheet. Again, growing on possibly what you've learned before. If you can figure it out, great. If you can't necessarily, it's not the end of the world. Your skill set in life cycle costing exercise, at least doing it in Excel, depends on your skill in Excel, if that makes sense. If you're very advanced or you're quite an advanced Excel user in relation to macros and Visual Basic and if scenarios and more advanced formulas, you can make the automation in your life cycle costing exercise more efficient. If you're not necessarily and you're starting on your Excel journey based on what we've just done here, again, depending on your Excel as it grows throughout your career, you get better and better at kind of automating your calculations. So this is just a basic example of a life cycle costing exercise, and I've added in a little bit more complexity than what you've done previously in relation to those spreadsheets. So taking the first item here, and there's only 7 items, and again, you could add in another 20 if you want, from the purposes of doing this exercise or following this particular spreadsheet. We got an air handling unit here, a little bit different than maybe a little bit different of a look, but essentially the calculations are the same with what you've done before. Item number, category, I don't have any particular national standard building elements breakdown structure or ICMS 3 breakdown structure here. You could add that in an additional column in terms of a code if you wanted to. This was originally an exercise I'd done for client, whereby they gave me a certain amount of information, and then I added a certain number more columns and calculations in terms of life cycle costing. So I was given a kind of an inventory of facilities management costs, and there was a category, a vendor name, an item name, a description of the item and its location, and as well as that, the actual install cost. So in this case here was one air handling unit, cost 20,000. So the initial install cost is 20,000. So this is, I guess, more of a kind of a facilities management exercise, an operational cost exercise, than it was a whole life cycle costing exercise where everything was calculated from, I guess, inception or construction costs all the way through operations costs and maintenance costs, et cetera, et cetera. So more of a sinking fund analysis on an existing building rather than kind of a whole life cycle cost exercise on a new building. Up here in the top left hand corner, now again, you can change the look of this and where this stuff is if you want, and add more sheets and grow the exercise, but it's just an example for the moment that you can build on. We've got a discount rate. Again, if you change any one of these items, it's automated, it'll change the costs in the Excel spreadsheet. So a discount rate, inflation rate, and obviously our real discount rate is calculated from the two of them. As you're aware, it's not necessarily one minus the other, but it kind of works out that way within a couple of decimal places in relation to that formula. The period analysis in this case is 60 years. Now you'll notice on the right hand side here in terms of the cash flows, it only goes to 60 years. Now you could extend that out to 100 years if you wanted to do an life cycle cost exercise outside that kind of cash flow period. If I I guess if I change this here to 40 years, what happens is you'll notice based on the automation in the cells, it'll recalculate it on 40 years. It keeps the 60-year analysis here, but it doesn't populate any cells outside the 40 years. So there's a bit of automation in there. There's a bit of, I guess, if scenarios that works out that calculation so that it won't populate cash flows. So you can change that there without really having to mess around with the actual columns on the right-hand side. So I'm going to just go back to 60 years because that's essentially what it was. Again, a little bit different here than possibly what you're used to based on the previous exercises. I'm going to do a year analysis 2024 in this regard. So this is the year that we're actually carrying out our analysis. Now, the reason I'm doing that, putting that year in, is that's going to be our start year. Now, you'll notice over here on the kind of right-hand side when we actually do our analysis that some of these items are actually installed a number of years ago. So this is some sort of inventory from a number of different buildings, from a number of different locations within buildings with different install dates. So even though we're doing our analysis in 2024, some of these items were installed in 2016, 2020, 2022, 2023, for example. So there's an offset start there. So if you're saying, you know, our new analysis starts in 2024 and there's a duration of 12 years in terms of kind of replacement cycles, well, it's 12 years in 2024 and then another 12 years after that, another 12 years. Whereas you've got an offset start when you've got a piece of item or a mechanical plant, whatever it is, that was installed a number of years ago, you have to kind of deduct that kind of set start from the duration. You'll see the best thing to do with these Excel spreadsheets is kind of play around with them yourselves and you'll actually see how the calculations work out. This one's fairly straightforward. There's not a whole lot in it. It's not a whole life cycle cost exercise, but hundreds of items. It's just an example, a template that you could possibly use for yourself down the line with some adjustment possibly. So let's take the first item. That's your data indices. Put in your name, own name there, data entered by yourself, even possibly. Taking the first item there, you would be all used to that in terms of quantity, unit rate, and cost. That period analysis is just going to take it from 60 there, from the data indices, and then I'm going to input, you know, replacement cycle. So it doesn't really matter. Let's say it's every 12 years. This air handling unit has an expected life cycle duration of 12 years and then needs to get replaced. So what's different here in this particular column, as I said before, is it was installed in 2020. So I'm carrying out my analysis from 2024, but it was installed 4 years ago. So you'll see that there's a bit of a calculation in there that calculates what the offset start is. So ultimately, you know, it looks a little bit more long-winded than it is, but ultimately it's 2024 minus 2020, it's 4 years. So we have an offset start of 4 years. So what's happening essentially out here on the right-hand side, we'll get to these columns in relation to the life cycle costs in a second. But ultimately here, there's a formula. If I click on that first one, you can see it up there. Now, there's some if scenarios there, if error scenarios, and ultimately it's calculated. If I double click it, if you can make sense of it, it's taking essentially the cost here every 12 years. So if I didn't have an offset start, that would be year 12. But because I've got an offset start there, it's calculating the first replacement item in the 8th year because it's a replacement cycle of 12 years minus the first 4 years because it's installed 4 years ago. So our first installation cost is in year 8. And then every 12 years after that. So now we're starting a new cycle of 12 years. So 8 to 2012 and so on through the 60-year analysis. So hopefully that's fairly straightforward. And then if I calculate some cost of all that, of that flow, now there's no discounted cost, there's no nominal cost just yet. Bear with me in that regard. There you'll see your sum real cost. So that is essentially your real cost, the real cost as of today's money of replacing that item in a 60-year period every 12 years with an offset start date as of today of 4 years. Now, based on the 5 or 6 different spreadsheets that you've worked on, you should have a handle on what that means and how that works. So that's your first cash flow. If you keep going on the right-hand side here, you've got a discounted cash flow, and that's fairly straightforward. There's some conditional formatting here that once there's a cell or once a cell is populated, it'll color it up. It just kind of maybe jumps out a little bit more than if there's no, I guess, color, if there's no fill in the particular cell. So if you're wondering what that colors are, that's essentially all it is a conditional format. All this is a discounted cost based on the real cost. So every year that costs are getting discounted. This is obviously to calculate my present value. So in year 8, in year 20, in year 32, etc., etc. So that essentially depends on what happened in here. In relation to your real costs, it'll populate it based on its discounted cost in relation to your present value on this side. Now, as I said, in this particular exercise, I didn't need to do an inflated cost or an escalated or nominal cost. So there's no escalated costs or inflated cost in this exercise. Have my real cost and my present value. So again, if you double click that, you'll see this formula is pulling the real costs from that particular cash flow. And you'll notice as well, if I just bring that across there, you'll notice there's a present value check, and that is on the NPV formula, and that's calculating the net present value based on the real cost with that discounted real cost. So it does the present value a couple of different ways just to see essentially does both ways work together. Are they both true? Are they both the same? And they are in this case. So I'm happy enough with that. So it's a way of checking, I guess, my cells. I'm just going to unhide that or hide that again. So it's the same for the other items in this exercise. Hopefully you've got a feel for what's going on there. Again, you're more than welcome to double click on any cell that has some automated, that has a formula in it, and try and figure out what's going on there. You may or may not be able to figure out those cells, those formulas, depending on your ability with Excel. Those of you that are very good with Excel, this will be second nature, and you'll be able to very quickly decipher exactly what's happening in terms of the calculations. Just maybe as an example here in item 15, you can add as many items as you want, but I put in floor finishes, just made up a name, Carlo tiles, they're ceramic tiles, what type of tile they are, what location it's going in, or the quantity, in this case, 60 meters squared, give it a rate, and there's my total cost. Now, from a population perspective, let's say we replace those tiles every 20 years. The tiles in this particular building and this particular item was installed in 2021. So 2024, it should give it an offset start of 3 years, and it does. And then because of automation is included in all those cells, if you click on any of those cells there below, even though it's showing nothing, it will populate once you've actually put the information here on the left-hand side. So you can see there, I've now got a different duration happening every 20 years because there's an offset date of 3 years. Doesn't go in year 20, as in the 20-year duration, it goes in year 17, and then goes possibly 37, year 37, and there we go. And then that's the actual real cost, 4,950, which is my, I just go back, which is my 4,500 plus the 10%. So another 450 euro added onto that 4,500 essentially gives me that for what I would believe it is 4,950. And then your discounted cost will pull that cell and discount it at 0.848 based on this particular discounted formula here. So again, that will make sense to you, at least in terms of the life cycle costs, present value, real cost, discounted costs from your previous experience in relation to doing those calculations. But by all means, add a few more items there, play around with it, see how it works out. It could be that this is the start of a template for you and you're adding more information to it, you're adding more functionality to it, you're adding more sheets, etc., etc. But it's a good example of, maybe more advanced example of where you can bring formula based on the, if scenarios and intelligence of that formula in relation to automating your calculations. So I hope you got something from that template. If you have any questions, by all means, send it to dermot.kelly@tudublin.ie. And I'll have maybe another example or another template based on a whole life cycle cost exercise for you in the next exercise. Thanks very much.